nice to see all those nice conversations and great architectural ideas in this conference. And today I'm happy to share our journey, how we transformed our data layer, and share some best practices, what we learned when we added Apache Hudi and Starrocks, and we used Onehouse for our system in Conductor. So a couple of words about our company. Conductor is the leading enterprise platform for agentic engine optimization, for answer engine optimization, and for traditional search engine optimization. And we provide different capabilities for our customers to understand their brand visibility in digital landscape in different AI engines like ChatGPT or Gemini or Perplexity, etc. And building the unified data platform helped us to bring together the content data, the search data, the technical signals about your website, and build wonderful product that we serve to our customers. But when it started some years ago, we just had this classic microservices architecture where like the customer sees our product as a single website, but under the hood, it consists of different set of features where each team separately owns the whole pipeline powering those features, from data ingestion, storing the data in the database, then exporting this data via API, and this API can power the features for the other teams, power different backend for front-end services. And like we had a lot of cross-team communication and dependencies with this architecture. Like some teams had to literally ingest the data from the APIs another team serves into their own storage, and then expose it as a feature in the final product. So this architecture, we could not really develop and ship our new features really fast, especially at the features that join data from different databases from that comes from different teams, and it included external, like a lot of delays because of communication, because of dependencies between the teams. Our interaction between the services quickly became messy. We had a lot of contract tests covering all those interactions to make sure that changes in one service do not fail the whole product. And we had a lot of like data duplication. Sometimes some data sets were duplicated more than 3 times and stored in different storages, and this approach was driving the costs up. So we started thinking about unifying the data, building the data lakehouse architecture, and so that allow all the teams to access the same data like in the same way and ship features much faster. So here I will show you one example of our pipelines, how it looked before the transformation. We had the data coming from external vendors ingested into the Kafka topic. Then we had some post-processing steps, which included like data, some cleanup, normalization. Then this data was passing data quality checks to reject some corrupted data. And finally, when this data was cleaned, then we had to merge this data that we collected externally with our customers' configurations, information about their websites, some configuration within inside our product. And later, this enriched with customers information data, it was coming into a big database that was serving for multiple features and multiple teams. One more problem you can notice here is that customer configuration is quite dynamic. It can change many times during the day, and we had to recompute this state in this database frequently, which added some like maintenance overhead, and like it wasn't like too optimal way to do the thing. So we started adding the layers of the data lake we started with the raw data layer, where we just saved all the data as it was coming from our vendors on S3 in the data lake, and it allowed us to, for example, reprocess this data if any component in this pipeline was changing. We could easily take this historical raw data and reprocess it in the pipeline, or we could troubleshoot. Given some problem, we could go back and see like what raw data was coming from the vendors. Next, we built the processed data layer, where it's clean, normalized data, passed all the data quality checks, but it's still customer agnostic data. We used Apache Hudi for this step because at that time we did deep evaluation of different technologies that could fit our needs. And Apache Hudi won this competition because it was trusted by many companies. It had the most number of integrations with different query engines, and we really wanted to experiment to find the engine that works better for us. And Apache Hudi provided transaction guarantees and also like open table formats. Again, it was able to provide us this flexibility with query engines. We also solved this problem with updates with customer configuration, as we again used Apache Hudi to store this customer configuration in separate tables. So in this layer, we kept like customer agnostic data separately, customer configs, which were frequently changing, we kept that separately. And then we also added Starrocks for our most intensive features that required really fast queries. We really experimented hard with all the optimizations for this processed layer in the data lake, but still for some features we required like subsecond latency, and for this purpose we chose Starrocks with internal storage using SSDs. While for some other features like scheduled reports, machine learning pipelines, or ad hoc analytical queries, this process layer with Apache Hudi, it's perfectly fine for us, and it serves its purpose. So at the high level, like those changes, they look pretty simple, but when you start implementing them, you immediately get a lot of questions and a lot of options how you should exactly do one step or another. Talking about data ingestion, we ingest the data from different data sources like S3 buckets, Kafka topics, MySQL databases, and even in other Hudi tables. And sharing the best practices which we learned. There are multiple questions that you should answer. You should make those decisions when you build the data ingestion. First is whether your data is mutable or immutable. If you go with mutable data, it can lead to huge write amplifications if you have a lot of data updates, and you can come up with, you can get Spark out of memory errors, and we saw such errors. If your business model allows append-only data, where you can just ingest new data as completely new records not related to the previous records, then it's great to go with that because it makes the ingestion lightweight. Then you can choose whether you go with merge and read tables or copy and write tables in Hudi. And we use both of these table types in our system. We use merge and read tables for some lightweight tables like config data, which is frequently changing. And we use copy and write for heavy pipelines. Together with append only, like immutable mode, let's say. Then when you decide how to build your system, you should think about what you care about, like fast ingestion of the data or fast performance of your queries. And typically you want to have both, but it comes with some compromises. In our case, we could achieve fast ingestion by switching to merge and read tables, where just new data arrives, it's stored as log files separately. Then we have a synchronous compaction process that does compaction into base files on the background, like every hour, for example. And in this case, the queries that read your data, they actually read from the read optimized layer from the base Parquet files. And so we allow some delay of the data updates before they are merged by compaction. In terms of architecture, so what we got eventually, so we were targeting the Medallion architecture. Typically, it's like bronze, silver, and gold layer. If you look at our architecture, it's kind of hybrid. We have raw layer, we have processed data layer, it's like silver layer, but the gold layer goes to Starrocks for very demanding features, use cases. And regarding partitioning and clustering, I will talk about it in the next slides. Those are also very useful techniques to optimize your data layout in Apache Hudi and achieve even better query performance. Partitioning is a fundamental technique where you partition your data. Typically, you partition it by the date-related fields, like by date or by month. Then when you ingest new data, you normally update the latest partitions. So at some point, partitions become immutable because you don't make updates to older partitions. Partitioning schemas, Hudi benefits from it because it uses partition pruning when you submit a query and you use partition key in your query parameter. Hudi knows exactly where to go and skip a lot of data. Partitioning is also very useful for data management, for example, data expiration. When you say that we store the last 2 years of data, for example, and anything beyond that we just expire, and it is as simple as just drop partition by partition. Also, you can set access control using partitions, like some of your departments access specific prefixes of the data. What to avoid here, partitions should not be too granular. They should have just the right size so that the navigation to the exact partitions happens very quickly. They shouldn't be skewed. We had an issue when some partitioning schemas were unbalanced, and the same query had different execution times based on which parameters you apply, which filters you apply in your query. So ideally, those partitions should be balanced and not skewed. Yeah, some link to follow up on this partitioning schemas. Another technique is data clustering. It's basically sorting of your data either globally or locally within those files, within Parquet files where Hudi stores your data. And it gives huge query performance benefits. It reduces the amount of data to be scanned because Hudi knows exactly like which range of data to skip and where your data sits based on your parameters in the query and based on your clustering schema. And normally it's hard to come up with a clustering schema that meets all the use cases. So typically we try to to choose such a clustering schema that covers 90%, let's say, of your queries. And we would normally pick from 1 to 3 columns that are most frequently used in the where clause in your SQL query. And this will give the most of benefit with this setup. Yeah, what to avoid here is the file size. When you cluster the data, the file size shouldn't be too big or too small. It should be just the right amount. And you should always try to include the clustering columns in your queries. A couple of words about open table formats. As I mentioned earlier, we experimented with different query engines. We were trying to find something that meets better our purpose. And thanks to the open table format that Hudi provides, it was really easy to plug different query engines or just downstream the data into Kafka or query it with Redshift, Spectrum, or Athena. Yeah, Starrocks query engine was our best bet, but for some use cases, yeah, we had to just switch to Starrocks internal storage. As of now, we have more than 100 terabytes of data, and it's constantly growing. We have more than 250 tables and flows running, and we run many table services like compaction and clustering on our different tables. And we are very grateful to our partner Onehouse. They helped us with all the experiments, all the setup, and to come up with like the best strategy that works for our business. Yeah, that's all from my side. Thank you.
Dude, good stuff. Well done. We've got some time for some questions and answers. So while folks are typing out their questions, I asked one a second ago, but also as a reminder, we have this poll. So folks, there's 90 votes so far. There's more than 450 people in this call right now on this stage particularly. There's another 500 on the other stage. Give us some votes. Come on, it takes one click. That's all I'm asking for. Get involved. Tell us what is it? What's your architecture? Andrei, what's yours? Just joking. I saw your talk. Trick question. Yeah. I'm kidding. So let me ask my question that I threw in the Q&A tab. I appreciate in your slides how you gave basically the things to note, like do's and don'ts type of columns. Knowing what you know now in this whole migration, in this whole overhaul process, what would you have done differently?
I think at this moment, some technologies evolved further, and we could try to experiment more with different query engines. Like Starrocks query engine sounds promising for us, so maybe we'll get back to that experiment. We'll see.
Okay, cool. So now another question from Barbosa asking, how do you handle compaction clustering? Do you pause ingestion or do you do it in parallel?
Yeah, actually we pause. In that specific case, we pause because for that pipeline, we don't have very frequent ingestion. So we have these intervals between the ingestions where we can freely run compaction and clustering without impacting our business.
Excellent. Well played. Well played. Well, it is time to keep on rocking and rolling, Andrei. I appreciate you doing this.